Alright, let's see here. It's got the wrong screen capture. Let me fix this. There we go. Alright. So, let's begin. I mean, I was planning on doing a little tutorial on Project 3. Yeah, so I'll explain a bit about Project 3. Yeah, so let's talk about Project 3. Oops. Okay. So, let's get rid of that. Okay, so the first thing we need to talk about is what the end goal of the game is. And so basically, if you've ever played something like Factorio, maybe, this is kind of it. The idea is basically you have two types of buildings. You either have a mines, two types of buildings. You either have mines or you have factories. Now, of course, this is a vast hyper simplification of Factorio. Factorial is not like this. So anyway, there's two types of buildings. Basically, mines produce raw materials, and factories take a recipe. A clicker game. I have no idea. Clicker games. Nope, no idea. Okay, so it takes a recipe and it turns some materials, right, into output. Okay. I guess it's a little bit like it's like what you can say is it's kind of like the crafting part of Minecraft, right? There's no movement. There's no, there's none of that stuff. But basically, imagine that your mines were you gathering material, and the rest of the game, right, is factories. So that's basically the idea of the game. Hey now. That's, no, not Minecraft, but bad. Minecraft, but simple, right? Because this is 201. No movement, no position. Yes, okay, I mean, let me just say, no, simple is good. What is, no. Okay, also, to all of these questions, basically the answer is, no. It's not Minecraft, and it's not bad, and it is simple. Okay, so that answers all of these questions. Okay. All right. Okay, so that's basically the idea here. Okay, so you have to do a lot of different things. So some of the basic, well, I take it back, right? It's not, there we go. Fixed. So, I might ban you guys. I know you're TAs, but, well, I haven't gotten to that yet, have I? So, what are the recipes, right? So the answer is that, for that, we have to, that's a good question. Basically, the recipes are things that are going to be provided. And so the whole point of this program is you have to two programs. One program is something that's going to take input, right, text input, and turn it into recipes that you then save in a file. And finally, you have the main game, which is going to take the recipe file, right, and use that to craft anything that is in that file, right? So basically, for instance, if you have say you have a raw material, and that raw material is, say, iron, and if each mine produces 5 per turn, you have to save that into your recipe file, right? And then you have, let's say that you have, like, say, iron sheets, and say it takes 2 iron to produce a single sheet, whatever that means, and so that also has to be included into your recipe file. And so basically, here you would just have 2 things. You'd have a raw material and you'd have a recipe, and that's really it. So that stuff has to be stored into a file. And so my suggestion is that you probably want to use some kind of dictionary objects. And well, no, yes, no. I mean, the answer to that question is it depends, right? So remember, you have to write a program that takes your text input and makes a recipe file. So whatever we input as the recipe file needs to be something that you can reproduce. So, all right, so if you have a dictionary object, the question is, how do I save this in a file? And so my suggestion in here that I'm trying to get you to use, yes, I think so, yes. So what you need to do is, yeah, so how do you save them in a file? And so for this project, I'm allowing the JSON module to be imported. And so there's a reason that I'm allowing JSON specifically. Now, JSON actually does stand for, I think it's like, what, JavaScript object notation or something. Or something like that. But it's become more than just JavaScript. It's become kind of a more industry standard. Yeah, no, so anyway, so here's the thing. So it's used for more than just JavaScript now. It's a good notation for saving data, right, that's stored into variables, into files. And it gives us, for free basically, the ability to save a dictionary and then load a dictionary back. So, so that's the point here. So let's start looking at let's look at this, and I guess, oh, I actually changed my font size. Okay, so yeah, let's talk about JSON. So how do you get it? What you do is you do import JSON. There we are. And so there's 2 important methods. There's going to be loads. It's load string, and I'll explain what this is in just a second. And JSON.dumps, which dumps the stuff into a string. So this is the one that converts from a string into a dictionary. And so that it basically is loading from a file. And so this dumps it out, so dictionary back to string. And so the good news about having a string is that's something, right? So why do we want a string object And the good news about that is that strings are savable into files, right? So you can save a string into a file, whereas you cannot save like an int or a dictionary or a class or something like that, right? Because those things are stored in RAM, and it's a much more complicated kind of structure, and it's very difficult for a file to really be able to know what to do about it. So, but anyway, it's good news for us because we can use. I'm allowing JSON, and here's why. And so let's make some stuff. Let's just say. Well, okay, so first let's just do an example where we save a dictionary. So let's save a dictionary here. So, test dictionary is going to be equal to say, hello, say 5. Maybe, yeah. Reverse of the country's problem where you put a file into a dictionary. Yeah, so basically you're going to be doing both things. You're going to put the file into the dictionary, and you're going to do it the other way around. So, goodbye is going to be 17. T-Rex is going to be 4. And who knows, right? Is going to be 3391. So the answer to that question is yes. Let's see. Where does it say? Okay, so, all right. So how do you save this dictionary into a file? So let's open a new file, say with test.json.json, or yeah, sure, test.json, and we'll open up in write mode as write JSON file. Yep, that's right. Man, I almost feel like giving you extra credit. So, okay. So how do we convert something like this? So basically the point is that we're going to do JSON.dumps, which is going to take an object. So the object here is going to be test dictionary, and that's going to give me the string that we're going to write. Right, the string that we're going to write is equal to JSON.dumps. And so then what we're going to do, so remember, when you use dumps, that's not actually dumping to a file. Is that forbidden? All right, fine. I mean, I don't care. I don't want to spend even 10 seconds explaining it. There we go. Done. I thought I might have taught it before. I forget now. Okay. Better. So, all right. So, yeah, we probably did. I don't remember. At this point, it doesn't matter to me. So, okay. So, writing the file with the JSON, right? So here's write file. Okay, cool. And then the only thing we have to do at the end is just close the file. Make sure you close your file. If you use open and you don't have with, then make sure you use close. Because if you don't, this could result in a file left open after the program terminates, and that could be bad. Okay, so anyway, so let's look at this thing. So what are the things that I want to go through? So first you have to open your file, then you create the string, and then you have to dump the string, right? Actually, or I shouldn't say dump the string, you have to write the string into the file, right? And so here's the thing, everything that you do should be in a single write. And the reason why is because you should make sure all the data that you need to save to the file is basically stored in one JSON string, and then write that JSON all at once. So for instance, let's just see what happens when we run this program. Nothing. So let's look. Where is it? Here's test.json. Here it is. So you see that this is basically like a dictionary. In fact, it's basically it is a dictionary, right? But the point here is that the JSON module knows how to read and to write these things, whereas like here we could have used the single quotes, but here they insist on the double quotes just because that's how they do it. And okay, so what if we wanted to do something a little bit more complicated? Like, what if you needed to say my raw materials, right, equals, say, iron 3, copper 2, silicon 1, something like this, and then let's say my recipes, right? And I don't know how you're going to encode them, but maybe you'll encode them as, like, I don't know, iron rod, and then iron rod is going to take what? It's going to take, say, iron 2, right? So something like that. And I mean, maybe you think to yourself, like, this is a really complicated structure, and it is. But what you can do is now you can say, okay, my total structure, right, equals something like this. You can say recipes, and then you can say my recipes, raw for raw materials, and then you can say my raw materials. And so here you have a what? You have a dictionary with, let's see, basically a dictionary with two dictionaries as values. So you have the keys, remember, they have to be immutable. So these can't be dictionaries, the keys can't be dictionaries, but the values are both dictionaries. So that's basically how that works. All right. So then what you can do is you can, let's see, do the same thing here. You can say my total structure, like this. And then you can write that into the file. Remember that when you do this write, it's going to overwrite the thing. So let's see what it produces now. Cool. So you see that it converted the tuple into a list here. Like here I have this as a tuple, but the JSON doesn't have the distinction between tuples and lists. It just has like arrays because JavaScript doesn't have tuples as differentiated from arrays. So anyway, so here's basically how it works, and yeah, so you can use this kind of idea to build your first program. Your first program should basically just make a raw material dictionary, and then it should make a recipe dictionary based on the input from that looked like the sample out. So if you look at the sample output, you'll see that there's for recipe maker, you'll see how it all works, right? Missed the blue. Okay, there we go. So you'll see how all this stuff works, right? And so you just need to mimic the behavior here in this part of the project description. So you just have to make it work like this. So basically, first thing you want to do is have it ask for raw materials, and then just ask for the rate. Raw material, rate, raw material, rate. And the only word that you're not allowed to use is either done or stop. So both done and stop should stop whatever it's doing. So for instance, you're inputting raw materials, done will stop that. And then here you're saying a circuit is made out of, you know, silicon 2, copper 1, and then stop, right? And then cog 1, iron 2, stop, factor 1, iron, or no, I'm sorry, output 1, iron is 10, cog is 5, stop, right? So it's a pretty simple bit of thing that you're going to have to do. And I've given you an example of how the JSON should look to some degree here. So you see that here it says like raw materials, and you know it has basically all the stuff in it that you need. And the good news is that let's do this as write JSON. And then here what you can do And so let's open, right? So read file equals open test.json. Technically, I don't need to put the read mode, but I'm doing it anyway. And then what I'm going to do is I'm going to say read file.read, like this. And I'm going to save this into JSON string, right? So this is not all the data that we need, right? So this is just a string with the JSON stuff read in. And you see now this is why I'm using .write, and I literally write one string into the file, and then here I call read once. So I just call read once, get everything out of the file. Presumably, yeah, hopefully. So you need to write, as I said, you need to write two programs. The first program you need to write is the thing that makes your recipe files, right? And then the second program you need to write is actually the project. So this, I would say that, you know, people should work on getting this recipe maker. Yeah, we'll create the test file, but we're going to create it using sample input. So so the test file, there is no test file, right? Yeah, exactly. That's what we should say. The test file is created using your code. So however you decide to stick the data structure into the file, that's how you should do it. Okay. So, and the reason why we want to just call read once is so that all the JSON data is shoved into the JSON string, and then you do JSON.loads, JSON string, like this, or some people call it load s, some people call it, no. So look at the project sample app. Look at how the project actually is called, right? So the first thing it asks in your program is enter the, you know, recipe file name, right? That's it. So you just give it the file name that you created. So we'll create a file, and then you save it under that name, and then we will load that file and run the program. So anyway, okay, so here's the thing. Now we can call this data, and let's just print out the data, right? So let's call read JSON like this, and let us see what happens. So here, what we see is now we've translated back, right? So that's the point here, is this has successfully translated from data in RAM to a file, and then back to the same data in RAM, right? Basically, this just allows us to store some of this stuff and use it over and over and over again. So you should only, you're not going to run this little recipe creator every single time. You're going to run it, you know, only once for every few test runs that you do. But anyway, so that's the point here. Okay, so that's how JSON works. JSON basically allows you to dump some data and then load some data, and that's how you're going to want to use it. All right, and so now let's do an example where I show you an issue with JSON. So let's see, what's a good class type? Say toy, and then how does it serve a purpose? Well, okay, I mean, if you'd like, you can write your own file format standard, right? That's the real thing that this does for you, is it's a format standard that allows you to encode things into a file. It's much more complicated than it sounds, right? Let's say wait, right? Yeah, I mean, basically, it lets you send a dictionary into a file. Now, I know that for the most part, you just look at this and you think like, oh yeah, it's easy. All you have to do is just print it into a string and then just shove that into a file. But I promise you that if you do anything slightly more complicated than this, then there's a lot more that JSON will do for you. And it also makes sure that whatever goes into the file is the right format for what comes out of the file. And it deals with escape sequences. Like, let's say that we have, for instance here, let's say that we have like a new line, here. It'll make sure that that gets dealt with properly, because otherwise the problem is if you just put it. Yeah, so it's an issue. Let me just show you this. To prove to you that like there is actually something going on here. So you notice here that it didn't just output literally a new line, right? It output \n\r. So it didn't just do something like, right? Because that would completely destroy the JSON structure. And so that's one of the main things that. Do I recommend using classes for the project? I mean, I've kind of left it up to you. Of course I used classes in my implementation, but that doesn't mean that you should necessarily do that if you don't want. I get the feeling like most people this semester are not loving classes very much, but yeah, I would say probably give it a shot. But anyway, okay, so here's the thing. Let me put the toy class. Oh, that makes me very happy. So, let me give you an example of something that doesn't work. Let's say that in this case we need, 4 toys, right? So, like toy 4, right? Or, let's try to save the data from the toy class. Let's create a toy class. So we create a toy, and we say the toy is a red ball. Well, let's call it a ball with weight, 0.25, and color is red. Okay, so here's the toy. And now let's try to save this thing inside of our JSON structure. So the toy, and let's do T. So this is the error that you're going to find that's going to happen if you try to do something like this. So let's try to write the JSON file again. And it's going to say, object of type toy is not JSON serializable. Okay? So, right, what the heck is that? Right, and so the answer to that is that the JSON structure doesn't know how to make this into a string, right? It looks at this thing and it just doesn't know how to make this into a string. So there are ways to do this. One way that I would say is that if you can make a helper function. So you can say like dump toy, and so what dump toy is going to do is it's going to give us back, instead of having it as a class itself, it'll just give us back a dictionary, and then let's say color, something like this. And when it returns this dictionary, then what we can do is we can say t.dumpToy, and then that will allow us to basically save all the information from a certain class into a dictionary, and then save that dictionary as a JSON file. And then of course you will have to write probably some kind of like load toy, right? Which basically what you'll end up having to do is you'll have to assume that the toy dictionary, And so you'll say like, self.name equals toy dictionary name. So this is not like the absolute best way to do this, and you might say, well, there's infinitely superior ways to do this, and the answer is, I agree, but this is definitely the quick and dirty way of doing it. And so this is kind of how you would save something that is a class into a dictionary, right? Save all the data from that class into the dictionary. Basically anything that's not a temporary variable, everything that you need to reconstruct this class on the other side. So you basically have to save everything from the class that you need, and then you will stick that in a JSON file. And then after that, what you're going to do is you'll need to have a function called loadToy, where you go backwards, where you take the stuff and you say, well, let's just do something like this. And then we can say t.load toy. And then where is the data stored? The data is stored in data toy. And then we can print t again, right? Because the problem is that when you actually print t, what's going to come out is, well, let's actually write it so that it works. There we go. Let's look at the JSON. So you see here that we've encoded the toy into the JSON file. And then what we're going to do here now, let's go back and read the JSON file. And when we do this, load all instances of a class into the same file. I don't really understand. Load all instances of a class into the same file. I don't know. So the point is that you've basically saved the thing and then you've loaded the thing. And that allows us to have, to recreate any class structure. You don't really need that for this project. So this is like hypothetical, really. I mean, so I was able to do 95% of, well, I shouldn't say 95%. I was able to do the entire project. Basically, all I needed was this, right? Because I think, so I used classes to implement the project, and I basically had like a recipe class. So there was like a list of recipes, right? And so in my list of recipes, I just went like for recipe and recipes, and I loaded them all into separate recipe classes. So it's not going to load all the instances of a class, right? It's only going to load the ones that you tell it to. And so like T is a single instance of the toy class, and that's the only one that gets dumped into here. So you're going to have to generalize this if you do this for the recipe stuff. Probably with a for loop. All right, so that's basically how, I think that's more or less what I want to say about JSON, at least for this semester. Yeah. Okay. So what other kind of stuff is necessary for this project? Basically, it's a lot of string parsing, unfortunately. I think the main thing about this project is that the first thing that you should do is either get your recipe maker working, or you should get your main event loop working, where you're just like select next action, right? And get all the commands kind of programmed in. So for instance here, if it says set mine 0 iron, then you're setting mine 0 to produce iron. You're setting mine 1 to produce iron. You're setting factory 0 to produce a cog, right, etc. Display mines, display factories. Like, just get all this working. You can even do this without recipes and just use strings initially, right? If you just have like all of this stuff set, and you won't know if it's producing valid stuff. You won't have any kind of, knowledge of that. But you can always just have it output, like factory 1, factory 2, factory 3, right? So you can have it do that. Get the end turn mechanic working, where it makes all the mines mine, and then it makes all of the factories make if they can. So remember, so the factories don't always produce whatever it is. So if you don't have enough iron, factory 0 will try to make a cog, but if it can't, then it's just going to stop, right? So and it'll wait for the next turn. And so that's how these things work. So basically, if factory 0 can make something, it'll make it. If it can't, it just won't. And so here, basically, here's like an example of all the stuff that you have. So here you have display the stockpile. The stockpile is, 40 iron and 5 cogs or whatever. And then there's also this display recipes thing. So basically, once you get your recipe maker, you should make the display recipe command, and just this is good because what this will do, this is basically a testing command. This is something which will allow you to know that that your program made the right recipes and imported them correctly from the recipe file. So that's what this command is doing, right? So generally, this command doesn't actually do anything in the game, right? It's just information, but it'll tell you where. It'll tell you when your recipes are loaded properly. So basically, what I would say is like get the event loop working, and then maybe get the recipe stuff working. So get this loaded in, and then maybe get the sets working, and then finish up with all the rest of the displays. The displays are generally easy. It's just displaying the stuff. So, but you definitely want those commands done, mainly because if you don't get those commands done, then you won't be able to know anything about what your program is actually doing. So always make the display commands first, and then you can make the set commands. And then finally, I would say make the endturn command. The endturn command is kind of the most, it's not the most complicated, but it kind of requires everything else to be in place, right? That's the problem with the endturn command, is that it requires the mines to be kind of working, and it requires the factories to be kind of working, and it basically requires everything else to be working, except, of course, for this thing here. So basically, how many iron are in a factory, right? So this is the bad grammar that I chose to implement for this command. This is the recursive command. So this is the one that you have to implement recursively. And the point about this command is, I think I kind of explained it. Where did I explain it? How many x are in a y, right? And so the reason why it has to be recursive, for instance, is this, right? It has to be recursive because let's say a video card, right, is made out of 4 RAM modules and 1 GPU, and then maybe some additional copper and some other silicon or whatever. So it's made out of 30 additional silicon, right? Maybe some other chips that are not actually part of the RAM or the GPU. And so, okay, that's all fine. But then a GPU is made out of 12 silicon and 5 copper. And RAM is made out of 10 silicon and 20 plastic. I'm just making up these, like, this is totally invented, right? These ingredients are totally invented, but the point is that you see that you found some silicon at level 1, so you went through all of the things that the video card's made of. So when you look at the video card recipe, it just says you need 4 RAMs, 1 GPU, and 30 silicon. It doesn't say that you need all these raw materials. But so here, then it'll say, okay, now what do I need for RAM? So basically the point is that when you actually want to compute the total amount of silicon that this thing needs, you're going to need to do 4 times 10, right? Because you'll need 40, and then here it's going to be 1 times 12, so that'll get us to 52. And then this 30 silicon, I just added this on the first level, and this is 30. And now you might say, well, okay, but that's easy. I don't actually need recursion. I just check everything at the first level and everything at the second level. So that's why I made this horrible thing. So this is basically just a counterexample to any thinking where you're like, oh, hey, I can just, right? I don't need recursion. I can just X, where X is non-recursive. So here's the point about the the non-recursive solution. If I ask you how many E's are used to make an A, right? And I say, okay, well, there's 7 B's, there's 3 C's and there's 5 D's in an A. And a D is made up of 2 E's and an F, right? So a D, you see, is always made, right? A D object is always made of an E and a 2 E's and an F, right? So that never changes. So that's because the recipe for a D is literally 2 E's and an F. Okay. But you see that you don't know how far down you have to go, because here it says, like if I just ask you how many E's it took, you would say, oh, I just go down 2 levels and I find that 5 times 2 is 10, so that's right, I just get 10, right? Cool. But then you say, wait a second, that's not it. That doesn't actually fix the problem, because, you know, why doesn't it fix the problem? It doesn't fix the problem because here, the next level here has 5 E's, so it's 3 times 5, but also now you have D's, which also unspool themselves into E's and F's, right? So that's why here it's actually 3 levels that you have to go down. And then, of course, here I made it something where a B is composed of some C's and E's, a D is composed of some, is composed of E's and F's, but so, and so you see that here you have to go down 4 levels. And so the thing is that if you don't know how many levels you're going to have to go down, which you don't, that's the whole point. You don't know how many levels or how many times you're going to have to pull apart a certain thing to see if it is like a raw ingredient or if it's the thing you're looking for and you can stop, or maybe it's actually also itself the product of a recipe where you then have to look inside of that recipe and see if any of the original products are in there. Now, the one thing I'm going to guarantee you, so remember the one thing that I will say about this is that once you see an A here, you're never going to see another A. And the reason for that would be that I would say, oh, an A is made up of 7 B's, 3 C's, and a D. And then I would say, oh, but a B is actually made up of 4 C's and an A, right? And so what is that really? That's actually, it's not just A, B, A. It's actually an infinite loop, right? Because if there was an edge that led back from B to A, that would mean going back up this little tree structure. And in the end, what that would do is it would basically show us that an infinite number of A's or an infinite number of E's or B's or whatever are inside of this thing, and that's no good, right? We don't want that. So I guarantee you, it is totally possible if you just say, you know, 18 flibbles make a widget, right? And then 2 widgets make a flibble again, right? And then you would say, oh, well, there's 36 flibbles inside of a flibble, right? Because, you know, 2 times 18 is 36. But then you would say, oh, no, but actually 36 squared, right, things are inside of a flibble, and 36 cubed, because you could go around that loop as many times as you want. You would just say, you know, basically if I say, let's simplify that a little bit and just say that, you know, where's my Inkscape? Here's the Inkscape. So basically if I just said like, hey, here's a widget. Here's a flibble. And then we say, okay. Right, so each widget is made up of 2 flibbles, and then each flibble is going to be made up of 2 widgets, like this. And then we see immediately what the problem is, right? Because if we do this kind of thing, then we're going to see that every single widget is made of 2 flibbles, which is not in itself a problem, but then if every flibble is made of 2 widgets, then now we're back to widget, we're back up here. So now you can basically say a widget is 4 widgets, right? And so if a widget, then either w is equal to 0, or actually in this case, w is equal to infinity. Right, it's like a GPU that's made of GPUs. Now, I mean, of course you might say like there's like a micro core or something like that, right? Like, you know, like a GPU has a number of small cores on it, but then you wouldn't then say that a GPU is going to go inside of a microcore or something like that. So basically here there's really 2 cases. Either w is equal to 0 or w is equal to some kind of infinity. In this case, it's some kind of infinity, right? And so the whole point about drawing all this out and explaining this is that we are not, not going to do this to you on this project for a whole lot of reasons. The first reason is that it would actually be a little bit more complicated, because just with that function, you would actually have to make sure that you never enter one of these loops, because if you enter one of these loops, then the number of components just goes to infinity immediately, right? Because it's just, you go through this loop once, you go through this loop twice, and then you're like, wait a second, there's nothing that stops this looping process from happening. Unlike in the other example here, where once you get down to an E, you're done, right? You don't have to worry that the E is then made up of A's, right? Because I'm guaranteeing to you it's not made up of A's. Whatever it's made up of, it's not made up of D's, it's not made up of C's, it's not made up of B's, and it's not made up of A's, right? Those are the things that it can't be made of, because those things are made up of them. So, Anyway, so that's the point. Yeah, a widget is made of a recursion depth. Yeah, that's right. So that's the point here. And so this function is the only function, right? The how many x are in a y function. It's the only function for this project that is required for recursion, okay? Or required to be recursive. And now, again, so as you see, recursion is necessary. So in order to make this function work, recursion is necessary. Can't really be avoided. But the other thing to say is that recursion is not required for any of the other functions in the project, okay? So unless, of course, you make a helper function for this one, whatever. This functionality is the only thing that requires a recursive process. Endturn doesn't have to be recursive. Display doesn't have to be recursive. Display. None of those are recursives. The sets are not recursives. And the loading the file is probably not a recursive thing either. So the only recursive part of the project is just the how many x are in y. And so obviously what I suggest you do is get as much of the rest of the project done first before you start messing with the how many of x in or y, right? That's correct. A widget is an arbitrary term for inside of exponent, Yeah, so there's no such, right now there's not recursive file I/O. None of this stuff is recursive, okay? Except for the one thing that I say must be recursive, so that's it. All right. Yeah, so what else should I say about this project? Well, I mean, if you're talking about recursive file input-output, the secret is actually that JSON.dumps and JSON.loads, these are most likely recursive functions, as it turns out. So, or if they're not recursive, they use a kind of recursive-y flavor that does something similar to recursion, or they use a stack, something. The point is that actually this stuff does do recursive file management, which is exactly the reason that you're not doing this in the project, right? That's the reason that we have made this optional, right? Made this open to you. That's right. So a flibble is 2 widgets. That's also true. os.walk is also a recursive. I mean, yeah. So there are recursive things. No. So yeah, if you use os.walk in this class, then you will be given a 0 for the project. Okay. Let's think. What else should we do? Hard to say. Part of me thinks we should just end the lecture early, and then next time we can do maybe Flask or GUI more. Maybe next time we do Flask. Today it was just JSON. So I'll load this up to the GitHub. This is a good little tutorial. You should be able to use it for your project. There's another JSON tutorial on my YouTube channel, so you can watch that as well. You know, if you didn't like this as much, and there's probably other JSON tutorials out there. So yeah, okay. Okay, I think actually, yeah, I'll just end class early today because we can, and yeah, I think it's over. I mean, I'm feeling like doing that. I could start Flask in 25 minutes, but I think it's better if I just do it all as one thing. So we'll just do it next time. Okay, that's it for today. Plus, I've taken a lot of extra time over these weeks. So it's time for me to end class early for once. All right, talk to everybody later.